All right, we're in probability here again. Discrete random variable. If you have your formula sheet, the mean, sometimes known as the expected value of x, equals the sum. Remember, that's the symbol sum of xi times p of xi. So value times its probability of each x value. What am I talking about in there? Okay, a discrete random variable, the variable that can only take countable number of values. Each value has a probability associated with it. So, for instance, here we've got a distribution. It says this is 1, 2, and 3, and the chances of 1 is 1/6, chances of 2 is 2/3, chance of 3, we have to figure it out. Well, okay, for a discrete random variable, the sum always has to be totaling 1. So if the 1 is 1/3, I think that was the first one. Nope, 1/6. And then the second one is 2/3. We have to figure out the other one. That's a total of 5/6. So we'll take 1 and subtract the 5/6. We'll get 1/6. So this missing probability is 1/6. In any discrete random variable, the totals of those have to be 100%. Okay. So with this, the table above, first of all, we can figure out the probability of a 3 in this group. Over here, we have difficulty. We're not going to be able to figure out probability 1 and probability 4. But we understand for two independent variables, x and y, the variance always adds. We can't add the standard deviation, something to remember here. So number 5, the tables above show part of the probability distribution for random variables x and y. If x and y are independent, then it says, and the probability of x is 3 and y is 4 is 1/16. X is 3, y is 4 is 1/16. First of all, it says, what's the probability that y equals 1? All right, so this one, x being 3, y being 4, we understand independent events would be, this is 1/6, which we had to find. Probability that it's 4 is unknown. I'm putting a question mark there. When you multiply through the table, there's a chance that this one's 3, this one's 4, which is what we're saying here. When we multiply them, we get 1/16. Okay, so we got to work backwards through the tree. This times this equals 1/16. So we're going to have to work backwards. I'm going to write it as an equation so it's a little clearer. 1/6 times whatever the question mark is 1/16. So I'm going to divide by 1/6. If you divide by a fraction, it's the same as multiplying by the reciprocal. So this should be 6/16 or 3/8. Okay. So you can use a calculator on that. The other way, you could just sit there and you could check. You could take 1/6 times 3/8, and you're going to figure out 1/6 times 3/8. So I'm going to do it this way: 1/6 times 3/8 just to check, and it does get us 1/16. So first of all, through that table, we always multiply probabilities with independent events. Okay. Haven't really touched on the only thing we've touched on the discrete random variable is, oh, but I got this wrong. So that's 3/8, but I need the probability that it's 1. So I was almost having to redo the whole video. So now we got 1/4 plus 1/4 plus 3/8, and we're missing the other part. So 1 minus 7/8 is 1/8. I was about to get a whole bunch of emails, answered a number. The first one is 1/8. That was tricky because it says, what's the probability y equals 1? So we were looking for this one. We found the 4, which is 3/8, and then we had to subtract. What we're dealing with in the discrete variables is those probabilities always add up to 1. All right, we're going to look at this next one. I'm going to make it a little bigger. For college-bound high school seniors, 1996, the nationwide mean was 505. With a standard deviation of about 110. Okay, so that's SAT verbal. Mean SAT math was 508, standard deviation of about 110, same standard deviation. If the two scores for each are added, the mean is 1,013. That's what we get if we add these two. So we're adding, we'll just call this X and we'll call this Y. So the mean of X plus Y is 1,013. But coming back up here, variance always adds. So you add the variance. What we're saying, if we're adding these variables, these are not variances, they're standard deviations. The variance would be 110 squared. The variance of the other one is 110 squared. If we're adding those two variables, we get the variance, which is 110 squared plus 110 squared. But then we turn around and we have to take the square root of those two to figure out the standard deviation. This question says, what is the standard deviation of the combined math scores? C. Okay, variance always adds when you're combining these variables. Okay, we're going to use that, I believe, on this. Now, if I haven't kind of rung a bell yet with what we're talking about, we would get these kind of tables. And we would have mean, standard deviation. This one, it says random variable X has a mean of 10 and standard deviation of 3. Random variable Y has a mean of 9 and a standard deviation of 4. If they're independent, which of the following describes the distribution of Y minus X? So if I take Y minus X, I'm going to take 9 minus 10. That gets me a mean of -1. So my mean is -1. At least, if I understand the order I'm going in, I can get it down to B, C, and E. But the standard deviation, when you're doing random variables, the variance adds. This is not the variance. So if we put a standard deviation of 7, we're incorrect. It's not 7. It's 3 squared plus 4 squared, and that equals the variance. 3 squared is 9, plus 4 squared is 16, so that's 25. We take the square root of 25, and our standard deviation should be 5. Variance always adds. All right, now this one deals with the discrete random variable formula. I was a little early in pointing that out. This is where we take the number times its probability and we keep adding with the summation symbol. We add there. So it says a department supervisor is considering purchasing one of two comparable photocopy machines, A or B. I got to make sure I read this because otherwise I'm going to do it wrong here. Machine A costs $10,000 and machine B costs $10,500, more expensive. The department replaces photocopy machines every 3 years. The repair contract for machine A costs $50 per month. Okay, so and covers unlimited repairs. So for 3 years, we would have to take that times 36 months. So the total cost of this machine will be the $10,000 plus 36 months, because that's 3 years, times, boy, embarrassing watching me type here, times 50, $11,800 cost of A. Now, if you're doing this on the AP test, make sure that you show the work, explain this is the cost of A. And now for B, it's $10,500, but it costs $200 for every repair, every time they come out and repair it. Now, understand, they're probably not coming out every month to repair these machines. They probably don't break down that much. But this one, it gives us these values that we are going to type in. Now, I recommend, again, you type these into lists. So you take your list, we'll call it X, and just for the sake of it, I'm calling it F for frequency. We could have 0 repairs, 1, 2, 3, and this is, it says it's the repairs, I believe, in any given year, 1 year period. So there's a 50% chance of none, 25% chance, 15% chance, and 10% chance. Menu 611, it's one variable statistics on whatever calculator you're doing. The number of lists is still 1. The list, I put it in as X, but you have to make sure you put your frequency as F. If you're using an Inspire, then it's got to be like L1, L2, where you put the second one, and then you click OK. If you don't get that frequency in, you're not going to get this right. Okay, so the mean for any 1 year period needs to be 0.85 repairs. Okay, so we would expect the mean in any 1 year period to be 8.5, but you're going to do that for 3 years. So over 3 year period, again, y times 3, because this is how many repairs in 1 year, but we're going to own the copy machine for 3 years. So that's 2.55 repairs. Now we should take that times 200 and get $510. So the total cost for this machine is $11,010 for machine B. So what I would recommend, if they're equal in caliber, is we would want to talk machine B in the long run is less likely to cost us the money. We'll save $790 by going with machine B. But there is a lot of math that you have to do there. You do have to understand how we got this and how we got that for that mean. We took 0 times 0.5 plus 1 times 0.25. Now, when I did this in class, I said go plus dot, dot, dot times 0.10. That's how many repairs. Again, if you didn't follow, we take no, that wasn't 2.55. That was the 8.85. Then we took that times 3, because we expect about a repair in a 1 year period, but we took it times 3, got us 2.55 times 200, getting us the 510 that we would spend on repairs. Now, of course, you can't have 2.5. Some students might say, well, we're going to estimate 3 repairs, and even if you go 3 repairs and you add 600, this machine is still $700 less. Okay, so a shopping mall has 3 automated teller machines, ATMs. Because the machines receive heavy use, they sometimes stop working and need to be repaired. Let the random variable X represent the number of ATMs working when the mall opens. We can have no ATMs working, 1, 2, or 3 on a selected day. What's the probability at least one ATM is working? Okay, probability at least one. Now this brings back the idea, anytime you do at least one, you can go 1 minus the probability of none. That's one way to do it. Pretty easy way to do it. 1 minus the 15 would be 85%. Otherwise, you can add these three up. But if we subtract the 15, since they add up to 100%, we're going to get the 85%. Okay, it's a great way to do that problem. You can do 21 plus 40 plus 24, double check, that's 85. What's the expected number of ATMs that are working? So that's the mean. That goes back to this formula, X times its probability. So I'm going to do this one the shortcut way this time. 0 times 0.15 plus 1 times 0.21 plus 2 times 0.4 plus 3 times 0.24. And what are we going to get? Now, for the mean, it's pretty easy. But I would type it in because sometimes you need the standard deviation. So I'm going to go through this again. Remember, put these in. This time I'm going to call it P and Q, just to use different letters so I don't have to restart that. We have 0, 1, 2, 3 ATMs. 15, 21, 40. And 24. All right. So the calculator, when you add the calculator page, we go menu 611 or one variable stats, whatever calculator that you're using. If it's an 84, I called my list P. That's the actual numbers. 0, 1, and 2, and 3. Those are the only possibilities it can be. My frequency list, though, if you don't put it in there, then it's just simply going to average the 0, 1, 2, 3, and you're going to average 1.5. So if you get 1.5, you forgot to put the frequency in. The frequency, it will make the mean come out to be 1.73. So we expect 1 or 2 working. Not much more than that, but you do need to learn to show the work. So you got to know that formula enough to be able to manipulate it. What's the probability all 3 ATMs are working when the mall is open, given at least 1 ATM is working? Now, this is the probability A given B, which I believe is on the formula sheet. That's this one. Remember, it's the probability of both things over the probability of the given. So make sure you know that. So it's given 1, at least 1 is working. Now, we calculated that percent. That's the 85% that we did in part A. So in other words, wrong thing. We've landed in this circle. This one didn't happen. We're in this 85%. Then it says, what's the probability all 3 are working? Well, the probability all 3 is the 24%. So both things, to be both things, that is the 24%. And if you divide that, that's our probability of a given value. And we get 282. Okay, given at least 1 ATM is working, would the expected value of the number of ATMs that are working be less than, equal to, or greater than the expected value from part B? Would it be? So given at least 1 ATM is working. All right. So if we know that, this one is kind of tricky. This became 282. So what we should do is for this one, we should take the 85 and calculate the given for this one, which would be 40 out of 85. And then calculate the given for this one, which is the 21 out of 85. So we get 247 and 471. Now we calculate the mean for this. These probabilities add up to 100%. If they don't, then we haven't done that part right. So here we're going to take 1 times 0.247 plus 2 times 0.471 plus 3 times 0.282. A lot of students right away, what they would do is they would mess up and they would only put these in, and you're going to get the same exact expected value because 0 times this isn't going to help. But when we do it this way, so we'll call this U and G. We got 247. And then we calculate these and use 611. Variable statistics on U and G. And the mean here is 2.035. We'd expect over 2 to be working. Now, you can actually take those values, you can test it out, this times this. 2.0, forgot, 35. So I would expect more would be working on average. Okay, no, pretty rapid fire video. Hopefully that helps. Goes through some different things. Given probabilities, discrete distributions, how to do those. Again, remember, kind of pick. What do you know? What can you get better at? What had you completely lost? Don't spend a lot of time on that. But study the things you know. And if you're like, I know how to do that, try it again. Do it on your own. What you put in at this point is going to be beneficial to you. I'd like to see people who are going to get 2s get their score up to a 3. All right, we're going to end there for today. Bell's ringing. Thanks for watching.